Hey guys, so this is a quick video showing you this software I wrote, which basically shows you what poles and zeros on the S-plane correspond to in the time domain. So we can put a pole pair down here, for example, and you can move it around, and you can see the corresponding effect in the time domain, which is this grey line here. So this would be the impulse response to a lossy LC filter, for example, and we can make it lossless by putting these poles on the imaginary line, like that. That's what you'd get. And let's move them back here, and let's have a look at the step response of this LC filter by putting a pole at the origin, and you get this. And so you can move them around here, and you can see that very clearly the pole pair closest to the origin dominates the response, and the one over here, whoops, if I can grab it. I really need to sort my recording out, this is terrible, I use my phone for everything. This has very little effect on the response. You can also stick zeros down, like that, and see what happens. Let's put the zeros on the real line, and you can move stuff with the keys as well. So we can slide it further out to the right. The more you add, the less accurate the response becomes, especially with zeros, because it has to differentiate the resulting pole transfer function in order to actually calculate the response. And the more poles you have, the more time domain convolutions it has to do of the individual responses. So the more you add, the less accurate it becomes. But it's kind of nice to get a picture of what's going on. So we can have a look at the ramp response as well of this system. Whoops, I've just put two poles down, let's get rid of one of them. By putting two poles at the origin, and that will show us the ramp response of this two-pole single zero system. Anyway, thanks for watching.